Alright, so there's two main types of bondings that can join or combine two or more atoms to make a new compound. And these are formed based on a few principles. Which one forms is based on a couple of different principles. It can either be the ionization energies, the electronegativities. Those play a role in what types of bonds are formed. So there's two main types. And the first one is when you have a metal and a nonmetal. When you have a metal and a nonmetal form a bond, they will form what's called an ionic bond. It stems from the word ion. That means you have an ion that is forming the bond. And I will go through and do that later, but an ionic bond is essentially the sharing of electrons. Sorry, the transfer. The transfer of electrons to form a new compound. Now, if you have I have a spider hanging off my document camera. So you can also have between two nonmetals. And when you have two nonmetals bonding, that's a covalent bond. So valent coming from the word valence, the outer electrons, sharing of, the sharing of outer electrons. Now these are just two brief definitions. Okay. And essentially what each type of bonding does each type of bonding is attempting to achieve a full octet. For each atom. Except in the case of hydrogen, it wants a duet 2, octet 8. They want 8 electrons in their valence shell, or to just have a full valence shell. So let's go ahead and define bonding first of all. Let's just make sure we all know what bonding is. Bonding. It's the sharing or transfer of electrons. Between two or more atoms. To form a new compound. And a compound I'm going to use this term a lot, so we should actually have a proper definition written down. I don't think I've done that previously. But a compound is a pure substance Made of 2 or more atom types. Made of 2 or more types of atoms. The key is there is 2 or more. So that means when we have something like N2O2H2, those are not compounds. Those are elemental forms of the atom. They're called diatoms, diatomic molecules. All right, now I'm going to skip this part just so I don't have weird little jumps in spaces. I'm going to start up here. I hope everyone's been enjoying the time. Seen some of you in the return to school. Which I suspect will be a practice for September. I don't know at this point if they will allow us to come back full time. We have to see what happens. This COVID-19 thing is a long-term situation. Ionic bonding. So let's give a good definition of ionic bonding. Let me read the one here and see what it says. Okay, so what is ionic bonding? Well, it is a bond formed by the attraction of positive ions to negative ions. So this is how we have positive ions and negative ions. And we should define ion just to be sure. Well, you know what an ion is. An ion is something that possesses a charge. Ion is an atom or molecule that possesses an electrical charge. We sure know that. So what happens essentially is, ionic bonding is the transfer. This is the simplified way to look at it. Transfer of electrons valence electrons. The transfer of valence electrons between, typically, a metal and nonmetal. So what we typically have is metals typically lose their electrons. So metals are the left half of the periodic table. And they have low ionization energies. It doesn't take a lot of energy for an electron to be removed. They also have low electric negativities. So they don't have a high attraction for electrons. So metals typically lose electrons. Oops, not go to cursive. Typically lose electrons to form positively charged cations. I'll define cations later. So metals typically lose the electrons. So think of a metal like sodium. Sodium is in the first column. It is very unstable with that electron on there. It can't easily get a full octet by adding electrons. It can more easily remove an electron and it would have a full octet and its similar noble gas configuration. So metals typically lose the electron, and then we can also have nonmetals. They're going to be hanging out in the solution and they are going to gain the electrons. And I say typically because there's always going to be some counter to something that goes against the grain, something that goes against the rules. We're not going to go over them here, but just so you know that it's possible. So they typically gain electrons to become negatively charged anions. And so after you form a positive and a negative ion, they are attracted to each other. These oppositely charged ions are attracted to each other. So think of them as like a north pole and a south pole. Those will attract one another. Ionic compound. Have overall charges of 0. An ionic compound will not have a charge. You can have ionic molecules, but the compound itself So let's quickly define cation and anion. A positively charged ion, sodium plus, Mg2 plus, lithium plus, and so on. Whereas an anion, and negatively charged. Cl minus, O2 minus, N3 minus, dot dot dot, ellipses, never know how to pronounce that. If you have trouble remembering it, so remember that a cation is Ca positive ion. T would be a positive. Where an anion would just be negative, N. And ion, a negative ion. Let's do some examples. take a sodium and a chlorine. So count of the valence. Sodium has 1 valence electron. Chlorine has 7 valence electrons. So what type of bond is typically going to form between these? Well, in this case, they're not going to share. There's a metal and a non-metal, so we have sodium as a metal. Chlorine is a non-metal. So that thing, first of all, is going to say, hey, ionic bond. And then essentially what's going to happen is this sodium electron, I'm going to draw it down here, Na with its electron, Cl with its 7 electrons. Neither are satisfied. Both want to have a filled octet, or a filled valence shell. So what ends up happening is sodium kicks away this electron and shifts it over to chlorine, leaving us with sodium plus. And now chlorine, it went from having 7 electrons to having 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. It has an extra electron, giving it a -1 charge. You can just use a minus sign for that. So we have, what compound is it going to form? Well, it needs to have a 0 charge. We'll have a plus and a minus. What's +1 added to a -1? 0 overall charge. And it is going to be written like this. NaCl. That's how you write your formula. Does that make sense? Okay, more examples. Okay, let's take a look at magnesium and chlorine. Well, magnesium, which column is it in? It's the second one, so it's going to have 2 unpaired electrons. Chlorine, again, number 7. 1, 2, 3, 4, 5, 6, 7. All right, how many electrons do you think magnesium is going to get rid of? Well, it has 2. It's a metal, first of all. So it has 2 electrons. It's a metal. Chlorine has 7 electrons, and it's a nonmetal. Okay. Well, how many electrons can chlorine possibly take from magnesium? Chlorine can't take both of those. It has room. Let's take a look at it. So let's see, chlorine transfers this electron over to chlorine. What do we get? We get Mg with a 1 valence electron minus, and we get a Cl, plus, and we get a Cl minus. 1, 2, 3, 4, 5, 6, 7, 8. All right. So what we have here is magnesium with 1 plus charge. It still has does it have a filled valence? Is the valence full? No, it's not a full valence. Does chlorine this one have a full valence? Yes, full valence. Do you think you're going to stop there? No, it wants to get rid of this electron. So what we're actually going to have is we're going to actually have another chlorine with 7 electrons. And what happens is this electron gets shifted over to that. I'm going to shift this table a little. Magnesium. It now has a 2 plus charge. Chlorine over here, we know it's happy with its 8 electrons and its 1 minus charge. Now this chlorine, it's taken another electron. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, all of these all have a full valence. The valence is full. This has a full valence. It has no electrons, meaning it's got the isoelectronic state similar to its closest noble gas. And then this chlorine has a full valence. Okay, everything has a full valence. Now we're happy. So let's double check to make sure our charges all add up. Do our charges add up? What charge do we have here? -1 plus a 2 plus a -1. -1 plus 2, +1. +1 plus -1 is 0. Awesome. So now we can say we have a compound. Now we need to write the formula for the compound. So when doing formula writing, we're going to write the metal first, Mg. And then we're going to write the nonmetal, Cl. But we have to identify how many Cl's we have. We have 1, 2. And you identify the 2 Cl's with a subscript number indicating how many. So MgCl2. So when writing formulas, write metal first. Subscript number. Subscript after the symbol. Subscript after the symbol indicating how many. Okay. Don't need to write one. Okay. Non-metal second. And then you'd repeat the same thing, right? Subscript. Easy peasy. Let's look at another example. I'm just going to work in this side of the column here. I don't want to start a whole new slice of paper just for that. Hey, how about I even draw a little line? Close-ish. Okay, more examples. Let's try sodium and oxygen. Why did I do that? Sodium, 1 electron. Oxygen, 1, 2, 3, 4, 5, 6. Okay. How many valence electrons in sodium? 1. How many in oxygen? 1, 2, 3, 4, 5, 6. Okay. Are these full octets? Are the valences full? No. 1 and 6, not full. What's sodium going to want to do? Is it going to want to gain 7 electrons or remove 1? It's going to want to remove 1. What's oxygen going to want? Well, it's at 6. It's going to want to gain, it can gain 2 electrons more easily than removing 6. So what happens is, well, sodium can give you 1. Yay, sodium being sharing is caring. So now oxygen has 7, and it has a minus charge. Its valence is full. It's happy. Sodium's happy. Oxygen, it only has 7 valence electrons. So what are we gonna do? You can get another sodium to hop in here. Bam, super sodium to the rescue. He's like, hey, oxygen minus. I've got 1 more electron. I'll give it to you. And you pop it on over there. Beautiful arrow I made there. So then we have a sodium plus from the original startup. Now oxygen. I have 1, 2, 3, 4, 5, 6. It was given to, so it's gone from 0 charge to an extra electron to a second extra electron. So it has a 2 minus charge. Sodium plus. Now oxygen has 8 electrons in its octet. It's happy. Both sodiums have removed 1 electron. They're happy because they have the same electron configuration as their nearest gas, noble gas. Let's add the charges up. I have a 1 plus a minus 2 plus a plus 1. Well, 1 plus 1 is 2. 2 plus negative 2 is 0. So it has an overall charge of 0. That's what we want. Okay. How are we going to write that? Write the metal first. Which one's metal? Left side of the table of that staircase with aluminum and gallium. Sodium. Na. How many sodiums do I have? 2. I have 2 sodiums. I have to put that in a compound. You use subscripts within a compound. Subscript of 2. How many oxygens do I have? That's the next one. I only have 1 oxygen. Na2O.